This is lesson 2.3 on indirect measurement using similar triangles. There are two warm-up questions, so please go ahead and pause the video and work these two problems, and then unpause it when you're done. This will give you an opportunity to kind of review stuff that we've already covered and see how well you are doing with that content. So go ahead and pause the video and work those two problems, and then unpause. Okay, so you should have these two problems done. We'll go ahead and work these through together. This first one here is just a problem solving, finding the value of the variable in a proportion. And so one of the easy ways to do that, we want to get x by itself, so we have to clear this fraction. We clear fractions by multiplying by the denominator. So we'll have 3/8 equals x over 25, and we'll multiply 25 to both sides. So this 25 dividing by 25 is canceled by the multiplying of 25, and you just have an x by itself. When you multiply fractions, you multiply top to top, bottom to bottom. So 25 times 3 is 75. And we'll still have 8 in the denominator. And then here, just divide 78 by 8 with a calculator, and you will get 9.375 as the answer. For this one here, this brings together a number of the properties of angles that we've talked about. Probably the first one is I'd start at this intersection here. We have two lines that are intersecting. The angle opposite of the 78, these are vertical angles, and vertical angles are congruent. So this should also be 78 degrees. Now these two angles and these two angles are along the same line, right? These two angles are shared by this line. These two angles are shared by this line, which makes them supplementary. So if you do 180 minus 78, that makes this angle 102. Because those two added together gives you 180, and that means its opposite angle, or vertical angle, is also 102. If we go into the triangle itself, three angles in a triangle should add up to 180 degrees. So if you take 180 and you subtract 59 and 78 from it, you should have 43 degrees left over. So that is going to be a 43 degree angle. Now to get the remaining angles here, it's important to note that these are parallel lines. And we talked about when you have lines that are parallel, that are cut by a transversal, that all the acute angles are the same measure and all the obtuse angles are the same measure. And so here we have an acute and obtuse. This one here is an obtuse, that's another acute. So if the acute angles here were 78, they're also going to be 78 here and here. And if the obtuse one's 102 here, then this obtuse is also 102. And that means this obtuse here is 102. But we know this one's 43, so if we take 43, subtract it from 102, that means this one must be 59 for both of these together to be 102 degrees like its opposite angle. Alright, that gives you all the angles that are shown here in that picture. Alright, so for the rest of this lesson, we're going to talk about three different methods that you can use to do what's called indirect measurement. So we can find out how long something is without actually measuring it, but by measuring other parts that are easier. So in this case, we're going to talk about the shadow method. So let's say we had a tree. We'll just draw a little tree here. And we wanted to find out how tall the tree is, but we don't want to climb up it. So if we have the sun shining here, the shining sun, make a little happy sun, will cause the tree to cast a shadow, right? So the angle of the sun would cause a shadow here to form. This is my shadow from the tree. And the shadow, we can measure its length, right, because it's on the ground. And we're going to assume that this ground is even, that it is not slanted, it's not hilly, it's a flat surface. Then we could take a person, and the sun should cast a shadow for that person at the same angle right? So as long as we're doing this at the same time, the angle to the sun should be relatively the same. It's so close that it's not going to matter. And so, these, we're going to consider these to be the same angle, and I can measure the height of the person, and I can measure the person's shadow. So that's what we're going to measure in these cases, is we can measure the height of the person and the shadow relatively easy, and we can measure the shadow of the tree relatively easy. And then use that information to find the height of the tree. So probably, let's go ahead and give some values here. Let's say the height of the person was 65 inches, and the shadow was 80.5 inches. And the shadow of the tree, if we measured it, it was 201 inches. And so we've measured the things that are easy to measure, right? The height of the tree would be very difficult, and this diagonal would be very difficult. But we do have two similar triangles. They are the same shape, it's just one is bigger than the other. So we're going to say this is a right angle, and this is a right angle, and then these angles are congruent because it's the angle to the sun. And that makes these third angles equal because it has to, because the three angles add up to 180. If those two are the same in this triangle, and those two are the same in this triangle, then these two have to be the same. So essentially we've determined that these are similar triangles. Because the angles are the same. Sorry, I had to pause the video there for a second. My grandson was coming in the room. So these are similar triangles because the angles are the same. And because they're similar triangles, we can say thus the sides are proportional. So as an example, if the sides were double on if two, let's say, put it this way: if the shadows were doubled the size, like if this shadow was twice that shadow, then this height would be twice this height. That's not the case in this particular problem. But however much bigger this is, the height is going to be bigger than this in the same proportion, which means we can set up a proportion. Now, I love these problems because they almost build themselves. If I take the height of the tree over the shadow, and we don't know the height, so I'll put X, the height of the tree over the shadow of the tree, and we equal that to the height of the person over the shadow of the person, we get a nice, easy proportion. And all we have to do is solve for X. Now to solve to X, we just need to clear this fraction. So to clear it, we'll multiply by 201 to both sides, which means these cancel out. Multiplying by 201 cancels dividing by 201. And then if we do 65 times 201 divided by 80.5, if you do that math, you'll get 162.298, which is about 162.3 inches. If we want to get that into feet, we can divide that by 12. And if you divide that by 12, and we'll go and pull out a calculator here, we'll see we'll get about 12.5 feet. So if I go to 162.3 and I divide that by 12, yeah, we get 13.5, so that's about 13.5 feet, or 13.5 feet. Alright, so I'm going to go ahead and stop this video here. The next part 2, is going to look at two other methods of finding the length of something using indirect measurement.